we're going to look at some very basics of matrix, or matrices in general. Okay? A matrix is a way to organize data. It's a way to organize lists of numbers into what's called an array. And these arrays will have various elements in a matrix. Each of the numbers inside the matrix is an element of that matrix. And we'll call this matrix, in our example here, this matrix will be rows and columns. So this will be a 2 by 3 matrix. We'll organize it by its rows and columns. This is said to have dimension of 2 by 3. M in symbols, in variables, this would be M rows by N columns. Okay. An M, in general, an M by N matrix is how many rows by how many columns. In this case, we have 2 rows and 3 columns. This would be a 2 by 3 matrix. It's called the dimension of our matrix. Okay. Any individual element is listed in there. This would be element 1, comma 3, first row, third column, and so forth. Okay. If you want to add matrices, we're allowed to add matrices together that are the same dimension. So you may add element by element. You may add element by element of 2 matrices with the same dimension. Scalar multiplication looks something like this. You would take your matrix and multiply it by some constant C. C is a constant. We take our matrix and multiply it by a scalar or a constant. And what this will allow us to do is then we can multiply each element by that constant. So if you need to add these 2 matrices together, if they're the same dimension, then go ahead. Are these the same dimension?
Yes.
Yeah, 2 by 2, 2 by 2. So that means we can add them element by element. So we'll get a new matrix that's the same size as far as dimension is concerned. And we'll take 2 plus -3. Will be our new first element. 4 plus 2 will be our new second element. 0 plus 4 and 1 plus 0 will give us the new bottom right corner. Okay, and then we'll combine those together to get our final answer. So you get what? -1, 6, 4, and 1 would be our new matrix. Multiply this first matrix by this scalar, by this constant 4, then I can multiply each element within this matrix by 4. So 4 times 3 is 12, -8, 0, 12, 4, 24 would be my new matrix when I multiply this by 4. Write yourself a new matrix by adding the previous ones will give us total sales. Okay. Last piece that you could do, last things we're going to see with these is to maybe, what if there are variables inside of a matrix? Being able to interpret what's going on, to be able to come up with and figure out what x's and y's might possibly be. So like in this example, man, how the heck am I going to figure out what x and y is in here? Well, I'd probably start with trying to simplify and make one matrix on the left, and get one matrix on the right, and then we'll be able to know something more about what x and y are. So first, I'll start by adding these two matrices together. I get 2 times, 2x minus 1. Negative 3 plus 4 is 1. 5 plus 3 is 8. Negative y plus 5 is negative y plus 5. First thing I did was I'm working order of operations here. So in these parentheses are two matrices. So I'll add the two matrices together to get one new matrix. And I'll add, again, element by element. 2x plus negative 1. Negative 3 plus 4 is 1. 5 plus 3 is 8. Negative y plus 5 is negative y plus 5. Okay. I still have this scalar multiple outside. So I'll multiply this matrix by this scalar 2, which means I need to multiply each element in this matrix by 2. So now this matrix looks like what? 2 times 2x minus 1, which is 4x minus 2. 2 times 1 is 2. 2 times 8 is 16. And 2 times negative y plus 5 gives us this new matrix. And what's it equal to? The right side. So I'll distribute all that stuff and your stuff. We'll just distribute here real quick. So distributing there, you get what? 4x minus 2, 2, 16, negative 2y plus 10. And that's equal to the right side of this matrix. 10, 2, 16, and 14. If these matrices are equal, that means every element inside of them is equal. Every corresponding element is the same. So that means the upper right should match the upper right. The upper left should match the upper left. The bottom left should match the bottom left. Bottom right matches bottom right. So in particular, how the heck can we set up an equation to figure out what x and y should be? How about this element needs to equal that element, and this element needs to equal that element. And now you have two equations. 4x minus 2 equals 10, and negative 2y plus 10 must equal 14. And you can find what x and y should be from there. Okay? Notice that 2 and 16s already match up, which is good. So that means the only way to have a shot is if these also match those. So figure out what x and y gives you. Are they both 3? So you get 4x minus 2 equals 10. 4x equals 12. X is 3. Negative 2y plus 10 equals 14. Y is negative 2.
Oh yeah. Sorry.
Y is negative 2. X is 3. Makes this matrix work.